Okay, good afternoon, folks. This is the second time I'm meeting some of you. I had a lab with the section 54 this morning. So what we're going to be doing is, as a second lecture of week 5, is to model a fastened assembly. Now, as soon as you see the word assembly, means that you have several parts involved. And when you say fastened, this fastened is different from fastened connection that you're used to and you have seen it several times. You actually create a bolt, okay? And you pretend that there is a preload in it, etc. Don't misunderstand a fastener with that fasten connection. That fasten connection that we have used on many occasions, is basically meaning two pieces are glued together. This is a fastener. This is a bolt. You actually tighten it, and it puts two pieces together. It clamps two pieces together, and they use it for, obviously, fasteners, etc. All right. So the problem that we're going to be doing is two plates like that, which are put together and tightened. And on the left side of these two plates, these are fastened, not fastened, I mean clamped. And on the right face here, we apply a force and pull it down. Okay, a couple of things. If you look at this problem and look at the geometry here, it is obvious that YZ is a plane of symmetry, assuming that these are perfect rectangles and that hole is right in the center, etc., etc. So YZ is a plane of symmetry. So if I actually cut this thing into half using the YZ plane, I will be cutting the bolt into half. Do not do that, okay? Because there is no guarantee that what you're going to do is going to work. Do not cut a bolt into two halves. Therefore, we don't use any planes of symmetry in this problem, okay? Now, I told you this morning, or some of you that had a class with me this morning, that I will prepare a video segment later on, standalone video segment, maybe 5-10 minutes, 10 minutes, and I'm going to post it because it shows you a very efficient way of naming part, product, and analysis the way you want it, or the way we want it. And we want it as your student ID number, your last name, plus a whole lot of other things that helps you and the GA, etc. Okay, so right now, when I solve this problem, I am going to ignore that because I want to show you that one strategy is to completely ignore those student ID number and your last name, and at the end, very efficiently tag those to anything that you have created. Okay? So if you see that I'm not calling these to be your ID number and your last name, that is not a coincidence, because I want to show you a way of doing it at the end. Okay. Before I do the problem, are there any questions? Okay, no questions. So the dimensions of this are given here. Okay, so I'm going to make, and on purpose, by the way, here, I'm not going to make these things the way they're supposed to be, like in the places they're supposed to be. I'm going to create them as 3 parts anywhere I want, and then I bring it in and I assemble it together. Okay? So let's start. Start with the product file. Product. Say okay. Let's make it. Okay, and notice that I'm not changing the name here, nothing. So insert a new part in there, part 1. Okay, part 1. I can change this name if it tells me. I can say the top one. I'm not going to use your student ID number, your last name. I'm going to say properties, top plate. Let me make it bottom plate. Bottom plate. This is the instance name. The part name is here. Bottom plate. Okay. Say okay. And let's make it. Double click on this. On a convenient plane, on that horizontal plane, I will draw this guy, 2 by 1. So a rectangle, and on purpose, I'm going to put it here. Let's make it 2 by 1. 2 inches. 1 inch. Okay. All right. Draw my circle. Somewhere here. First of all, make it exactly halfway between top and the bottom. So the top line, control the bottom line, control the center. You make it equidistant. Okay. And then the diameter of this, or the radius of that, I'm not sure. Let me see now. The diameter is 0.25. 0.25. Okay. And it is positioned half an inch from the left edge. Okay. So dimension between the center and that to be 0.5. 0.5. Okay. Exit. And this is padded by 0.125. These plates are 0.125 thick. 0.125 inches thick. There. This is my bottom plate. Go there. Insert. New part. No. And call it top plate. Right click. Properties. Top plate. Top plate. And top plate. Okay. Let's make it. Double click on this. On a convenient plane, on that horizontal plane, I will sketch a square 1 by 1. Right here. Square 1 by 1. 1 inch there. 1 inch here. Put a circle in the middle. And clean it up. Clean it up means that center it. Left line, control right line, control the center, make it equidistant. And the same thing from the top. Top line, control bottom line, control center, make it equidistant. And the radius of this is the same as the radius of that guy, which is 0.125, diameter 0.25. 0.25. Okay. Exit. And pad it by 0.125. Excellent. This is also done. Notice that I haven't saved anything. I can, but I will wait for a few minutes. Insert, next one, new part. No, I'll call it the bolt. Right click, properties, bolt. This is the instance name. And the part name is down here, which is called part number, of course, in CATIA. Terrible. Okay, double click on it. Make it, and the thing that we're going to make is something like that. So this is 0.1 and this is 0.5. The shank is 0.5, or actually 0.1, yeah, 0.6. And yeah, the radii are 0.125 and 0.2. Okay, so let's go ahead and make it. Do it any way you want, with a mat, with a pad, with a multi-pad, with a shaft, whatever you want. Okay, so on that plane, I'm going to draw 2 concentric circles. You really don't care how you do it. Another one. right there. Dimension, this is the size of the hole. We are assuming that there's tight fit. There's no, wiggling around inside of that. You can make this thing thinner if you want. I don't know. It's up to you. And this bolt head has diameter diameter. I think it's going to be 0.4, right? Because this thing was the radius, so diameter is 0.4. So that's the bolt head. Now, I don't know, use multipad, use pad, whatever you want. Let's use a multipad here. Let's first of all exit. Okay. And I mean, if you want to practice a multipad, fine. So this one is the head. Let's make it 0.1. And this one is the shank. Let's make it 0.6. Let's see if it looks right. Okay, that's good. Excellent. Do this thing any way you want. All right, so all the way to the top level. Now, if you are concerned that, you know what, I may lose this thing, I think the computer crashes, why don't I save it? You can save it, there's no problem, okay? That business of renaming these things so that at the end you have your student ID number and your last name and then this stuff, we can do that later, even if I saved it now. So let me save it just in case. File, say management, there's the product, save as. Let's go to the desktop. It's a new folder. Let me call it Bolt 1. No, let me call it, how about, okay, this is what, lecture, section 1. How about section 2? You guys are section 2. Section 2, I'll call it, I don't know, temporary, temp folder. Whatever you want to call it. Say OK. And then say OK. So what happens in that temporary folder, in that temporary folder, you have this. So desktop, temporary folder, section 2 temporary folder, you have this stuff. Don't worry about it. At the end, I'm going to show how you add your student ID number and your last name to these things. Okay, so let's go back. All right, now the only reason I did it is that in case a computer crashes, I'm going to lose this thing if I don't save it right now. Okay, I did it. So we're going to assemble this thing. Why don't we fix something here? Fixing means fixing as an assembly constraint. Anchor, right here, anchor, right there. Good. Now, coincidence between, for example, this face and that face. Update, it shifts it up a little bit. Okay, good. Coincidence between this edge, the different ways of doing it. So this edge, update. Okay, very good. Am I happy? This is not fully constrained, by the way, but am I happy the way it is? Sure I am. If you want, you can put another constraint here too. This face and that face coincidence so that this cannot, hinge about that edge. Now, coincidence between that axis and this axis, update. Now I want this thing, pull this thing up. So let me pull it up. I don't like it the way it is. Move in the Z direction. And let me tilt it about the Y direction. Oh, no, hang in there. Tilt it about the, let's say, this axis. It's a rotation about that line. That's terrible. That's not what I wanted to do. It'll do the job. Okay, one more coincidence. Not this coincidence. Did I do the axis to? I did axis to axis. Right. Coincidence between that face and the axis to axis I already did. I'm pretty sure. That guy. Okay. Update. Looks good to me. Okay. So you're going to save these. And then we're going to go to generative structure analysis. Katia sees 3. Oh, material, material, material. I made that mistake this morning again. Okay, let's do that. Material, everything is made out of steel. I told you that this can be done in the generative structure analysis, but it's better if you go back and do it the way you know. Okay, right there. Save. Okay, now go to generative structure analysis. This time we will not complain about material. There we are. We're doing a static analysis. Let me change the rendering. There. Okay. Now, this size, we're not assessing accuracy here. Okay, that being the case, I'm not going to fool around with elements as long as it let me do that. If it gives me an error message saying that your element is too big, I'm going to fix it. But aside from that, I'll leave it the way it is. This is, let me see now. This is for the big plate. This one is for the top plate, and this one is for the bolt. This guy is for the bolt. Okay. Now, all the things that we know also applies here. If necessary, I can ask you to do a mesh refinement around the hole, etc. I'm not going to do that, but you should be able to do it. We did it this morning. We did it on Friday. Okay. Why don't we save this thing, by the way? File, save management. There's the analysis. I'm perfectly happy with the way it is right now. This analysis name, you're going to change at the end, put your student ID number and your last name in front of it, but that's okay. Right now, we just leave it the way it is. In that folder was called section 2, temporary folder, right? Yeah, good. Okay, a couple of things. I want to make sure that this plate does not penetrate that plate. Remember, you're tightening this bolt somehow, or maybe with a screw, maybe there are threads, or maybe there is a nut down there. We don't have a nut. Pretend there are threads, okay? If you tighten the nut, then this cannot just go through that. You should push it, but should not go through it. So we create a connection, and I'm going to call top plate, bottom plate, top plate, bottom plate, okay? And we say the top plate, for example, order is not important for the first component, and so I select the surface, the surface of the top plate. For the second one, I'm going to hide this, and I'm going to select the bottom of this plate. It creates a connection. You can see that, and this connection is right here, and this is contact. You know that these are not glued together. These are contact. You put this plate on top of the other plate, okay? And the contact is right here. There we are. And it puts the contact thingy there. And we're good. So let's bring this back in the show mode. Okay. Then we know that this, when you tighten the bolt head cannot go through the top plate. Okay. So that being the case, we do another connection between the, I'll call this thing bolt head, and top plate, and patiently do this. So hide, the order is not important, so I can select the top plate, the top of this plate as first component. The second component, I'm going to hide this, and I'm going to select the bolt head right here, right there, that guy. You say okay, and again we know that this is contact. We know this is contact. It's right there. You see this? You say contact, and this guy, and that guy, contact. Okay, good. Let's bring this thing back in the show mode. Okay, very good. Now, how do I tell Katia that this is a bolt with some amount of pre-bolt tightening load? So here's what you're going to do. You create a connection. Well, let me ask you a question first. If you wanted to tighten, if you wanted to clamp these two plates together, where would you put the thread when you know there is a thread in the bolt, and then there is since I don't have a nut, I have to screw it in, right? I have a thread on the hole also. Where would you put the thread on the hole? In the hole. See, there are two holes here, the top hole and the bottom hole, and I don't have any nut here. So I want to screw this thing into into this so that it holds these two together. Would the thread in the hole be on the top one or the bottom one? Just say it. Just say it. Is it the top hole or the bottom hole?
Bottom.
Yes. Correct. Correct. Very good. Very good. You can put it in the top one, but it's not going to do anything. Excellent. So here's what we're going to do. We create a connection between the shank of the bolt right there, first component, and then hide this. And for the second component, the connection, because we're going to be using a bolt, is in the bottom hole. Okay, now we want to tell CATIA, hey, this is a bolt. So look at the face-face connections. You have used contact before. You have used fasten before. You have used shrink fit before. Hey, look, there's a bolt here. Bolt tightening connection. You click on it, it says, where is that connection? It's this last one that I created, right? This last one. Then unfortunately I didn't give it a name. Okay, fine. And it says, what is the tightening force? In other words, you use a torque wrench to, when you clamp two things together for precision purposes, you don't do it with a hand. You use the torque wrench in order to find out what is the force, what is the moment, and then that translates into force. And since you're fourth-year students, you have done bolts and things like that probably in your design for failure prevention course. So I put down 50 because that's what the problem said. And I have no idea. Is it too much? Is it too little? If it's too much, it may break the bolt by plastically deforming it. If it's too little, that's not enough clamping force, etc. Now, I'll tell you what. You have two options here. Either opposite or the same. Okay, if one doesn't work, try the other one. But if you look at your bolt, you see that there's your bolt, there's the bolt icon. This is in the right direction. If this was flipped, then it would not work. You will see that. I make it opposite like that, whatever it is. If I flip this, it becomes the same. See that? See that? The bolt head must be on the top. One more doesn't work, use the other one. 50 pounds. Okay. Okay. Almost done. Finished. We're going to clamp this face and that face. I'm not going to even put a load on this thing. All I do is tighten this so that they're stuck together. Later, I'm going to put a load here. No problem. So, first of all, we save this. And then we're going to run it and see what happens. If you had to pray once before, now you have to pray a few times because these problems are harder. No problem. So let's see what happened. All I did was to bolt these two together. Bolt them together means, turn the bolt so that these are tightly pushing on each other. Deformation. That is okay. Could be okay. I don't know. Deflection. This is without any force. You can see that. This is without any force. Anything that you don't like, you get rid of. Double click on it. Don't show me all those gooey thingies. These are contact elements. Just show me the stuff. Oh, not this guy. Not this guy. That guy. Okay. All right. This is a displacement. Okay. Very small, very small. Look at the stresses now. Okay. The stresses are not big either. Remember, I don't know, 50 pounds. Is it realistic? I don't know. So these stresses are kind of okay. If you want to see the bolt, the stresses in the bolt, which is about 1,700, obviously there's very little stress here. You know that. Just show me the bolt. Just show me the bolt. So the bolt is right here. That makes sense, okay? You expect stresses to be large here. You don't expect any stresses here because remember the thread was in the bottom. The thread was in the bottom plate over there, okay? And of course you expect the cap to go down because this is really pulling on the head, etc. Now, let's put everything back where they are. Okay, save this. Okay, first of all, are there any questions about what I have done so far? Oh, I forgot to put the load. Yeah, is that what you're going to say?
I have a separate question.
Yes, go ahead. Go ahead. Go ahead.
Would there have to be some sort of connection between the bolt shaft and the top plate?
That's very good because I am pretending that the bolt shaft does not establish contact and go through those holes. If in doubt, and if there is such a close, tight fit, then you better put contact between them two. But pretend, just for a second, pretend that the diameter of that shaft was maybe a third of diameter of the hole. You know it's not going to establish. Well, actually, you can have a thread there if it's one third of that. The short answer to your question is yes. If you want to be let me see now. If you want to be modeling this thing a better way, you better also create contact connection between the shaft and the outside surface of the hole, etc. Yes, yes. But I didn't do that. I didn't do that because I have a reason for not doing it. We'll come to that in a minute. Okay. Are there any other questions? Now remember, the reason that you put these two together is that because you want to load it. So let's go. This is just the bolt tightening process. That's it. Now we want to put a load here. We want to pull this thing down. Okay, so let's go ahead and deactivate this plot.
Sir, can you go over the third connection you made, please? The
Third
third,
one.
yeah, the one with the bolt. Was it the inside shaft and the bottom of the?
Yeah, the shaft of the shank of the bolt. The shank of the bolt is that thing that you have threads on it, for example, and the hole inside the bottom hole, inside of the bottom hole. Yes, that was the connection.
Okay, thank you.
Okay. Oh, yeah. So let's see now. Oh, we want to put a force. That's the whole point of clamping these things. You want to put a force on it, you want to make sure. So let's do, I think I said 100 pounds, I don't know, on this face, downward, minus 100. These are all fictitious numbers. I don't know. See that? Right there? You see this? Good. And you say, okay, and run it. You'll see that the bolt is going to be in action. It's going to put these two together, and it's going to, of course, this load is going to pull this thing down because these are clamped together. The top plate is also, supposed to follow that. Okay, let's look at it. Let's look at the deformation first. Scale, scale, scale. There. Okay, good. So notice that this guy wants to go down. These are clamped together, and that's why this is also pushed down. Okay, and same thing with the stresses and things like that. Scale, scale, scale. There. This is an indication that you have a bad mesh. Whenever you see checkerboard patterns like that, means your elements are probably pretty bad. Just let me try something here. Let me make this thing parabolic element. It will take a little bit longer, but I want to see if that checkerboard pattern disappears. Okay, that checkerboard pattern means that your elements are either too big or the type is not very good. And worse if it's too big and not too good. So let's run it. Okay. Yeah, it's going to be taking a little bit longer. Not much. Follow instruction on the test. If it says use default element size and default element type or linear, use linear. Use linear. Don't do anything on your own. You're not going to lose mark. It's just that, you know, we're trying to protect you too. Don't put something small that's not going to finish. There we are. Let's look at the stress pattern, which was checkerboard before. Yeah, that's better. Definitely that's better. The first one is total junk. This one, I have no idea because I have to do mesh conversion study. Okay. Now, here comes the moment of truth. And the moment of truth is that, okay, I did all of this work. Now I have to submit my work because it's a test or a homework. Here's what I'm going to do. I'm going to go to File Save Management. Okay. Notice that my product was called product. I didn't change the name. My analysis was called analysis. I didn't change the name. These one, for my own benefit, I changed them as top and the bottom and bold. Now here, at the very bottom, on the left side, it says pattern name. Let's take the analysis, for example. Let's take the analysis here. Actually, let me not take the analysis. I'll take all of these. This guy and that guy and that guy and that guy. Not the last two, because the last two we really don't care. You don't have to give it to us. And I put your student ID number. What is your student ID number? 1, 2, 3, 4, 5, 6, 7, 8, 9. Dash. You're still Einstein. Einstein. And let me say apply pattern. It took whatever you had before. Right in front of it, it puts 1, 2, 3, 4, 5, 6, 7, 8, 9. Einstein. Okay? Now, I want to take this analysis and save it in a different folder. And it's going to take everything with it because I'm going to say propagate directory. Save as. Let's go to a folder. Desktop. I'm going to call a new folder. This is to be submitted. To be submitted. Okay. And say okay. Come on. Save. Come on. Propagate directory. Good. Close it. Let's go and see what we have in that folder. The name of the folder was to be submitted, was it not? To be submitted. These are the 5 files that you have to submit. All of them. Any of them missing, we can open it, you're going to lose marks. I mean, obviously, if you can't open it, what are we going to mark it for? Now, it's entirely up to you how you want to give us your file and how you named it. I just gave you a way of doing it, probably more systematically. I don't know. Okay, close this. Close that. By the way, the old one is still here. See, this was the old one. Remember the old one? Before I put it in a different folder, before I gave it a different name and I put it in, it's still there. Okay, but I don't need it. Now, let's go back here. You might say, okay, well, this is great. The problem is if I have 100 bolts or if I have 500 rivets, well, what the heck am I going to do? Am I going to make 500 bolts? No, first of all, you're not going to make 500 bolts. You're going to make one bolt if the bolts are all the same. You're going to make one bolt and use it, keep using it as an instance. But even that can be very time consuming and unnecessary. Unnecessary. Because after all, when you put these plates together, you don't care about the bolt. All you want to make sure is that these are clamped against together with a certain force because you want to load the structure. So there's something called a virtual bolt. Let me do the problem for you with a virtual bolt where you do not actually model the bolts. So let me kill this. Okay, let me kill that. Start a product. This time I'm not going to be, well, you know what, actually we still have time, so I'm going to be very, very specific about how I do this thing and how I rename it, the efficient way that we discussed. So we're going to do that, basically a brand new problem, except that we're not going to model the bolt. Okay, so here's the situation. Insert new part in there, bottom plate. Remember I called it bottom plate? Would you like me to rename this thing bottom plate, or you remember? You probably remember. Double click on it. On that plane, I will sketch. It was 6 by 1, I think. What was it? No, 2 by 1, not 6 by 1. 2 by 1. This is 2. This is 1. Make a little hole there. Clean it up. Top line, control, bottom line, control, middle, or the center. Make it equidistant. And also position it from here to here. I think it was 0.5, if I'm not mistaken. 0.5. And the diameter of it was 0.25. Yeah, 0.25. Say OK. Exit. What is that? Exit. Pad it by I think it was 0.25. Was it 0.125 or 0.25? Pad of 0.125. Sorry. 0.125. There is my bottom plate, which I left it as part 1. Bad idea, but I left it as part 1. Insert the second component, the second part. No, it's called part 2. That's going to be the top one. See, it's a bad idea not to call these things proper names. Okay, so double click on this. Go to the part, select the proper plane that you wanted. Well, that's not proper, the one that you feel comfortable with. For example, XY, and sketch on it. Remember there was a square, 1 by 1. 1 by 1. Excellent. Draw a circle here. Center it, the top. Control the bottom. Middle, control middle. Equidistant. Left, control right. Control center, equidistant. And if you don't want to learn these things, just say from here to here 0.5, from here to here 0.5. Fine. Okay, and the diameter 0.25. .25. Okay, exit, pad it by 0.125. Very good. Product, apply material. If everything is made out of steel, let's assemble it. I didn't have to do it like this, so I could have made it right here so that it looked like it was assembled, but I'm just trying to remind you how else can be done. Anchor something, and this anchor has nothing to do with not moving, with fixed, clamp. It has nothing to do with that. These are assembly constraints. Strictly speaking, that is not true. Coincidence between this axis and that axis, and coincidence between, for example, this plane and that plane. And I'm not updating, I'm doing it at the end. Coincidence between this plane and the bottom plane. It's a good idea to update these things one by one to figure out any mistakes. But anyway, there we are. Okay, so save everything. And remember, I told you that you don't have to wait until the end and do that trick. Why don't you protect yourself? Save it right now. File, save management. This product, save as. Desktop. Desktop, new folder. How about calling it virtual bolt? What about that? Virtual bolt. Say okay in there. You say okay and okay. Notice that I do have a folder called virtual bolt somewhere. Desktop. Virtual bolt right there. Your product, your part 1 and part 2. See, I said it was not a good idea to leave it like this. That's okay. Now, the next thing is we're going to go to generative structure analysis. Notice we did not model the bolt. Okay. These hurt my eyes. I don't like it. Good. Anything that you don't like, you can clamp, by the way. I'll leave it the way it is. Okay. I've shown you how to make things finer around the hole and things like that. And I'm going to ask you on the test. That's okay. All right. We just leave it the way it is. So, where is this guy? These are clamped. Okay. I still don't want this plate to go through that plate. That's dumb, you know, if we don't do it. So we have a connection. First component is this plate. Hide it. Second component is the bottom plate. Okay. I'll give this thing a good name. Top, bottom plates. How about that? Just so contact. Top, bottom plate. How about that? That's good enough. Whatever makes you remember next time you come and look at this. Okay, we're going to make this thing contact right there. And remember, I told you that do not always look for a box with two little boxes sitting on top of each other as the connection. So you'll get that. But what I'm saying is that these don't always look red. Sometimes they look just a white dot, etc. So here's a contact. Where's this? Contact. No, contact. That guy. You can make it fasten, but fasten means that it was casted like that. The bottom and the piece was together. And of course, there's no reason to tighten it anymore. There's no tie them together anymore. It's not fastened, it's contact. Now, where's the other guy? Let's bring this thing in the front. Very good. Now, we want to create a connection. We want to create a virtual bolt without actually modeling the bolt. Well, what does the bolt do anyways? It creates a clamping force, which is the bolt tightening force between these two. So that being the case, I need to create a connection between that face and that face, the usual connection thing, the usual one. So I'll call it holes. Okay, how about that? Holes. You remember what I mean. Okay, that face, and for the second component, the bottom face. You see that? Create a little red thingy here. That's this one, holes. And I make this thing virtual bolt tightening. Now, these, the face one, where I did the bolt tightening, that's not virtual. Go to the distance connection property. You have used the first one. Remember? I don't know, when was it? Yesterday, 2 days ago? I can't remember. Beams, when we did beams. Anyway, point to point. When did I do that? No, I didn't do it for you yet. I haven't done it because we did it on one occasion, perhaps. But I did the videos for next week's assignment. That's where I thought I'd done it for you. No, it's going to be done. Now, distance connection property. Just look. This says virtual bolt tightening connection. The one next to it is a little bit more sophisticated, but this says virtual bolt tightening connection. You click on it and you select that guy, and all you have to do is to put the tightening force. 50. And there is no same or there is no opposite and things like that. You don't model the bolt, but you model the effect of the bolt, basically. Say okay? All right? You don't have to create a contact between the bolt head and the top face, because there is not. This is a virtual one. If you have 1,000 bolts or rivets, this is the way you do it, probably. You don't model every single rivet or every single bolt. And okay, is there a question? You got to
Yeah,
speak up.
just a quick question. My connection lagged out for a second. Could you just show me what you clicked for the holes general analysis connection?
I did this face, the face of the top hole and the face of the bottom hole.
Okay, yeah,
For
thank you.
for first component, the order is not important though.
Yeah, I
Okay.
just didn't see. Thank you.
Yeah. Let's run it now. Oh, let me save this thing because I don't remember. I haven't saved the analysis yet. File, save management. We haven't named any of these properly. The analysis, save as, we leave it the way it is. Not in this folder though. Remember I called something virtual bolt? It's so easy to screw this up. Virtual bolt in that folder. Very good. Let's run it. No bolts. But the tightening effect is there through virtual bolt. Okay, let's see it. Okay, yeah, that's kind of thing we had before. You don't expect exactly the same thing. Stress, okay, so fine. Notice that the bolt head is not modeled, but these are being clamped together, and that's why you see a weird color here. Now, this is fine, and now we're going to put the load on it. So deactivate this, and remember what we did? We put 100 pounds down here. Where is that 4C? On that face, 100 pounds downward. Save it. Run it. By the way, I'm using parabolic, and remember last time I changed it? So it still uses that. Okay? So let's see now. How does it work? Displacement. Reset the scale. That's scary. There we are. The actual numbers. Okay. The stress. Reset the number. Reset the graph. Okay. No bolts. If you had 100 bolts, rivets, this is how you do it. Now, is it as accurate as doing with a bolt? The answer is hell no. But what choice do you have if you had 100 of these? Okay. Now okay, before we stop this thing, remember I have to show you how to save these things, right, with your name and everything. And let me see what this fellow wants. Can you speak up if you have a question? Okay, I guess there's no question.
He was asking if you have to use linear mesh for the exam.
Read the instruction. We will give you instruction. If it says use linear elements and default size, unless otherwise stated, use it. You're not going to lose mark if you don't, but why would you do that? Why would you take a chance of using an element, parabolic, and accidentally you're going to make it very small, and then you sit there and this thing goes on and on and on? Why would you do that? If you're asked to use parabolic, for example, or of a given size, do it. If you're only asked to refine the mesh, just refine the mesh. I don't care how small you are. Don't make it too small. I want to make sure you can make it small. I don't care how small, because all of these things are nonsense, these numbers. Okay? Does that answer your question? Yes? I hope so. Okay, now come the big moment. We go to File, Save Management, all that stuff that I recklessly created. What I want to do, first of all, I want to put some prefix. Oops. So set up this, Shift, Shift, Shift. Don't worry about the last two. Put a prefix. Are you still 1, 2, 3, 4, 5, 6, 7, 8, 9, Einstein? Let's change your name. Not Einstein. Bohr. Apply pattern. 1, 2, 3, 4, 5, 6, 7, 8. Bohr, and the rest. And now take the analysis, because if you take the analysis and propagate directly, all this stuff is going to go with it. Save as, folder, desktop, folder, to be, Bohr to be submitted. Board to be submitted. One board. Okay. In there, save, propagate directory. Okay. Now you have a clean folder there, which is board to be submitted. In it, you have your student ID number, your last name, analysis, your product, your 2 parts, and these things we don't want because we're going to run it for you. These, all 4 of them, you drop into the, if this was question number 2, in the question number 2 thingy. If this was question number 2, I would suggest that after Bohr, you put down problem number 2 so you don't get confused. Okay, I run out of breath here. So let me, let me see if there are any questions. Okay, so let me stop the recording here. Stop the recording.